Wow, math got really hard when they started adding these big S's to the left of the equation. How am I ever going to pass this class?
That's where I come in.
Who are you?
Please. This has everything you need.
The playbook? This says everything?
Well, no. It has one kind of obscure thing, but the other students' projects will teach you the rest.
Sounds good.
So, for the integral of x squared plus 3x over root x plus 4, we're going to use the denominator as our u substitution, so u equals root x plus 4. That means that x equals u squared minus 4, and that's what we're actually going to substitute in. So, we put that in and we leave the denominator as it is. As you see here, the substitution for dx cancels with the denominator, leaving an easy polynomial integral in terms of u. We simplify and integrate. Don't forget the plus c. Resubstitute for u, and there is our final answer. Now you try.
The problem we're working with is the integral of x squared minus 10x over the square root of x plus 7. The first step is to take the u substitution, so we set u equal to the square root of x plus 7. After we take the derivative of both sides, we find that du equals half of x plus 7 to the negative 1/2 dx. And we also isolate x to show that it equals u squared minus 7. We then go back to our original equation and substitute u squared minus 7 in for every place that there is an x. Also, when we substitute out dx, the extra x term along with the du cancels out with the x term in the original equation. After that, we have a relatively simple integral, and we solve that in terms of du. After this, don't forget to add the plus c at the end of it, and finally substitute the square root of x plus 7 back into the problem for our final answer. Okay, I got that. But what about a problem like this?
Here, this one fits it perfectly. Okay, now we'll take the integral of x squared over square root 16 minus x squared. And to do that, we're going to set up a triangle with the sides 4, x, and root 16 minus x squared. So x is equal to 4 sine theta, root 16 minus x squared equals 4 cosine theta, and theta equals sine inverse of x over 4. So we plug those into our equation, and we get some nice cosines that cancel. And then we're going to use a trig identity, remember sophomore year. Sine squared theta equals 1/2 1 minus 2 cosine theta. And once we plug that in for our 16 sine squared theta, we eliminate all the squareds and we're left with easier trig integrals to do. So we take that integral plus c, and then we resubstitute back for x. So we use a trig identity to get to this point, and then it's just easy simplification, and we have our final answer.
One last thing.
Perfect, because you only have 3 wishes.
Really? I wish for $1 million.
No, you don't.
No, I don't.
Alright, this one is the integral of 1 over x squared plus 14x plus 53. Right off the bat, we're going to complete the square. Now, we're going to set x plus 7 equal to 2 tan u. So dx equals 2 secant squared u du, and u equals tan inverse of x plus 7 over 2. We plug that in right away and distribute from where we substituted for dx. And we're going to use the trig identity of tan squared u plus 1 equals secant squared u. That means that our whole equation is going to be in terms of secant squared, and they cancel, leaving us with the ultra simple integral of du over 2. The integral of that is just u over 2, and we plug in for u, and there's our final answer, plus c. Last one.
We're taking the integral here of 3x over the square root of x squared plus 4x minus 5. We first set x plus 2 equal to 3 secant u and take the derivative of both sides. We then isolate u, which means that u equals the secant inverse of x plus 2 over 3. After that, we substitute out all the x terms with u terms, including the dx, which leaves us with a longer expression, but all in terms of u. However, with this longer expression, we can cancel out lots of terms, and we end up with the integral of 9 secant squared u minus 6 secant u du. After that, we take the integral and we add the plus c at the end. The final step is to substitute the x terms back in, and then you have your answer. Thank you, mister. Hold on, where'd you go?